What is array indexing? Array indexing is same as accessing an array element. How we can access an array element? That is array indexing. You can access an array element by referring to its index number. The indexes in case of numpy arrays starts with 0. The array index of first element is 0. And the array index of second element is 1. And third element is 2. And nth element is n minus 1. Then how can we help of an example? For that we are importing numpy package and creating an n-dimensional array using the method np. Print arr of 0 statement will print the array element at 0th index location. So the case of the element at 0th index location is 1. So see the output is 1. Print arr of 2 plus arr of 3 will take these two elements and will find the sum. The element at second index location is 3, third is 4, sum is 7. So the result is sum 7. In the next statement, again we are creating an n-dimensional array. But there's a change in this n-dimensional array. See, it has 2 dimensions. This is the first index and this is the second index. Print the fifth element of second dimension. We want to print the fifth element of second dimension. So see the parameter that is used to print. Fifth element. So the second parameter is 4. And the dimension is second. So the first parameter is 1. Suppose we need to print the fourth element of first dimension. So the parameters will be like this. If the array name is ARRR, 0, 3. So fifth element of second dimension. This part is considered as second dimension. And which is the fifth element in that second dimension? 10. See, the result is 10. Again, we are creating an n-dimensional array. And what you are printing? Print ARR of 0, 1, 2. See, while considering 0, here again it's of 2 dimension. So, 0 means the first part. And in that 1 means the second part. And which is the element 2. So, in this part 0 comes 4, 5. 5's index location is 1 and the index location of 6 is 2. So, the result will be 6. Again, see the next example. Here again we are creating an n-dimensional array. We are printing the last element from second dimension. So we need second dimension. So the first parameter should be 1. And we need to print the last element. So that we can use the location as -1. So -1 is always used to refer the last element in case of list array and all in Python. So this is a simple example showing how we can refer to an array indexes or how we can refer to array elements by indexing. Next, slicing arrays. What do you mean by slicing in Python? Slicing means taking elements from one given index to another given index. In order to perform slicing, we can pass slice instead of index location. That is, we have to specify the starting index location and ending index location. So one way is to provide 2 locations, start and end. We can also perform slicing by performing step value too. We can say start, end, followed by a step value. If we do not pass start, by default, the starting location is considered as 0. And what happens if we do not pass the end value? The length of array is the dimension. And if we do not pass this third parameter step, by default, step value is considered as 1. See how slicing is performed using numpy package. For that we have to import numpy package, create an n-dimensional array using array method. For slicing we need to specify parameters like start, end and step. So in a slice, the start index is always considered in Python and the end index value is excluded. We'll see in examples. See the first print statement, print ARR of 1 colon 5. The elements from the index location 1 to 5 will be sliced, but the element in the fifth index location will be excluded. So the result will be the elements in the index location 1, 2, 3 and 4. See the value 2, 3, 4 and 5. See the next print statement where the end index is skipped. So all the elements from the index location 4 will be the part of slice. So the result is 5, 6, 7. In the case of next print statement, we are omitting the start index. So by default, the start index will be 0. So the elements in the index location 0, 1, 2 and 3 will be the part of slice. Since the end index is 4, that element will be excluded. Next is an interesting example. See the slice -3 colon -1. -1 refers to the last element of the array and -2 second last element, -3 third, the element third from the last. So print -3 colon -1 where the start index is -3, that is third element from the last, and the end index is -1 which is omitted. So this element will be omitted. So the result is 5, 6 in this example. See in the next print statement we are doing a step value, we are specifying a step value which is 2. By default step value is 1, that is after one element the next element is traversed or taken. If the step value is 2, we will skip one element in between. See, start index 1, then end index 5 which will be omitted and the step count is 2. So this value will be omitted and the next value will be considered. Result see 2, 4. And see the last print statement was start index is not specified and end index is not specified. Step count is taken as 2. So from 0th index location, alternate elements will be the part of result. See. So this is a simple example showing how slicing is performed using numpy package in Python. We'll see an attribute of numpy array, shape attribute. So what is shape of an array? Shape of an array is nothing but number of elements in each dimension of the array. Numpy arrays have a special attribute called shape, and this attribute returns a tuple with each index having the number of corresponding elements. We will see this with a simple example. For this we are importing a numpy package and creating an n-dimensional array. Here the dimension of array is 2. So print arr.shape will display a tuple with first parameter as dimension and second parameter as number of elements in each dimension. Number of elements in each dimension is 4. So that's the result of first print statement. The next statement, again we are creating an n-dimensional array and the dimension is specified as 5. So see, while printing, it will be displayed with an array with 5 dimensions. And what is the shape of the array? The dimension of each part is, a dimension is specified like this, and the fifth dimension has how many elements? 4 elements. So that's the result of the last print statement. So shape is an attribute that returns a tuple with each index having the number of corresponding elements. We'll see how to reshape an array. Or what do you mean by reshaping array? What is reshaping? Reshaping means changing the shape of an array. So what is the shape of an array? It's the number of elements in each dimension. So by reshaping we mean that we are changing the shape of an array. That is, We can add or remove dimensions or change number of elements in each dimension. So reshaping an array in case of Python means we can add or remove dimensions of an existing array or change number of elements in each dimension. Example of reshaping an array. For that we have to import numpy package, create an n-dimensional array. Here I have declared a one-dimensional array. And I am reshaping that one-dimensional array to 4, 3. That means in the next redimension or reshaped array, we have 4 arrays with 3 elements each. See the output. In the next set, we are reshaping a one-dimensional array to 3-dimensional array, which means, see the parameters 2, 3, 2. That means outermost array consists of 2 arrays. These are the 2 arrays. And what is inside? There are 3 arrays with 2 elements each. That's the purpose of 3 parameter. What should be the dimension of outermost array? Then the innermost array, number of elements in each array. Again, I am declaring a one-dimensional array with 9 elements, reshaping 3, 3. See, same result. 3 arrays with 3 elements. In the next case, I am specifying a parameter -1. This is for unknown dimension. In this case, Python will automatically calculate the dimension. So how we are reshaping? We are reshaping this one-dimensional array to 2 outermost part. This is the first part and this is the second part. And each part consists of 2 arrays. And number of elements we are specifying -1. So Python will automatically calculate since there are 8 elements. First part consists of 4. Second part consists of 4. The first part there is 2 array. So it will automatically take 2 elements to each array. So this is an example showing reshaping. Flattening the arrays. Flattening array means converting a multi-dimensional array to one-dimensional array. For that, again we are using reshape method with parameter -1. See, here ARR is a multi-dimensional array and I have called reshape method with parameter -1. See the result. It's a one-dimensional array. It was initially a 2-dimensional array. Now the dimension has changed to 1D. That's called flattening the arrays. Then numpy arrays can be copied and viewed. What is the difference between this copy and view? The main difference between a copy and a view of an array is that copy is always a new array, but view is just a view of the original array. The copy owns the data and any changes made to the copy will not affect the original array. And any changes made to the original array will not affect the copied array. So copy means just a copy. So we can make changes either in the copied array or in the original array. But what happens in the case of view? View does not own any data. So any changes made to the view will affect the original array. And any changes made to the original array will affect the view. So that's the difference between array copy and array view. Array copy will always create a new array, whereas array view is just view of the original array. We'll see this with an example. See, here I have created a one-dimensional array and created a copy. And after creating the copy, ARR of 0, I'm inserting a new value to this array as 42. Then while printing ARR and X, see there's no change in the copied array. Copied array is what is copied. And there is change in the original array since I have inserted a value 42. So this is how a copy works. We'll see how a view array works. For that, I'm importing a package numpy and creating a one-dimensional array or n-dimensional array, and x equal to ar.view will create the view of the original array ARR. Now I'm modifying the original array and printing both original array and view. See, the changes are reflected in both. Again, we are making some change to the view array, but the changes will be reflected in both original array and view array. So that's an important array concept, array copy and array view. The concept of numpy package, how an array can be created from existing data. For that, the method used in the numpy package is numpy.asArray. And asArray function is very similar to numpy.array function. Numpy.array function is to create an n-dimensional array, and asArray function is also similar to numpy.array function, except that it has fewer parameters. This routine is very useful for converting a Python sequence. We can either convert a list or any sequence to an n-dimensional array. For that, we can use this asArray method. See, the parameters are, asArray has three parameters: A, dtype and order. A is an input data which can be in any sequence, any form means Python sequence form. Can be either a list, list of tuples, tuple of tuples, or tuple of list. And dtype by default, data type of the input data is applied to the resultant n-dimensional array. And order, as told earlier, C for row major and F for column major. By default, the order is C. The second and third parameter is optional. So asArray method is used to create an n-dimensional array from an existing. How to create an array from a sequence. For this, again, we have to import the package numpy, and I've declared X, which is a list, and created an n-dimensional array from this list. So print A will print the array. In the next example, A is equal to np.asArray x, dtype equal to float. The data type of this array is float. So see the result. The result is an array with elements with floating point value. Here in the second set, again we are creating an n-dimensional array from a tuple. 1, 2, 3 are the elements of a tuple x, and we are creating an n-dimensional array from this tuple and assigning it to A and printing the value. So this is how we can create a n-dimensional array from existing sequences like list, tuple, etc. Next, how array can be created from some numerical ranges. For that, again, another method is arrange. This function also will return an n-dimensional array object containing evenly spaced values within the range. So the range can be in this format: start, stop, step, and dtype. Start, the start of an interval. If omitted, by default will take 0. Stop, the end of the interval, and this number will not be included. Step, spacing between values. By default, step size is 1. And dtype, data type of the resulting n-dimensional array. If not given, data type of the input will be used as dtype. We'll see an example of arrange function. For that, import numpy package. X is equal to np.arrange of 5 will create an array in the range 0 to 5. 5 is excluded. So print X will print the array with elements 0, 1, 2, 3, 4, and the last element 5 was excluded. The next case also we are creating an array in the range 5, but the data type of the elements are float. Linspace function, numpy.linspace. This is a function that is very much similar to arrange function. The difference is that in the linspace function, instead of step size, number of evenly spaced values between the interval is specified. See the parameters of linspace function. Start, starting value of the sequence. Stop, the end value of the sequence. But here the end value will be included if the endpoint, the fourth parameter endpoint is set to true. Number of evenly spaced samples to be generated. By default its value is 50. Endpoint by default it is true. If true, the stop value will be included in the sequence. If endpoint is set to false, it is not included. Restep. If true, return samples and step between consecutive numbers. The data type is a data type of the output in dimensional array. Use an example of the linspace usage. For that, import numpy package np.linspace 1025. So we are creating an array with starting value 10 and ending value 20 with 5 elements, 5 evenly spaced elements in between. So the 5 evenly spaced elements will be 10, 12.5, 15, 17.5 and 20. Since 12.5 and all got, we got the result as floating point value. And see in the next case, np.linspace, same example, but here endpoint is set to false. So the 20 will be excluded. So how the elements will be evenly spaced with a gap of 2, 10, 12, 14, 16, 18 are the 5 elements between 10 and 20 evenly spaced elements since the end value is excluded. Then in the next one we have put restep to true. So see the array 1, then 1.25, 1.5, 1.75, 2, and again we are printing the step value also together. Since restep is true, between 1 and 2 we need to evenly place 5 elements. So these are the 5 elements and their step value is 0.25. So this is the difference between arrange and linspace. In case of arrange, the range or the how it should be evenly spaced does not specify. But here we can specify how the element should be evenly spaced. Next is another method, lock space. This function also returns an n-dimensional array object that contains numbers that are evenly spaced on a log scale. Start and stop endpoints of the scale are integers of the base, usually 10. See the parameters are start, starting point of the sequence as base, stop, the final value of sequence again as a base, num, the number of values between the range, endpoint, if true, the stop is the last value in the range, base of 10 space by default, it is base 10. D-type, data type of the output array. Here also not specified, it depends on the input argument. Simple example. We are creating a log space between 1.0 and 2.0 with num 10. See the result. This also will create an array. In this video we have seen what is array indexing, how we can slice an array, how we can shape, reshape an array, then many array creation methods from a range, from a log space, linspace, etc. So thank you.